And so I'm looking at question number 2a in our assignment, and it's given us a piecewise defined function. It says x squared minus 4 over x plus 2. As long as x is not equal to 2, and I think that might be a typo, and then we need to choose a value of a when x is equal to 2 that's going to make this thing continuous. Okay, that's the question. Now normally what you do is you would take a look at this function and you would say, oh, of course, I've learned to factor ever since I was in grade 9, and this is the reason why. You would factor the top. You would look for factors that are common to the top and bottom. You'd cancel them out, and then you'd come up with this much simpler linear function, and you would keep the restriction. And so this, the fact that there's a factor in the bottom, means that x just cannot be equal to negative 2. What does this look like? Well, obviously this is the line x minus 2. And if we take a look at it, sure enough, it's the line x minus 2, and we look all the way down, and when we get to negative 2, when we get to negative 2, there we go, I was in the wrong place. Sure enough, this function is undefined. And so if we want to make this continuous everywhere, when x is equal to negative 2, basically, we have to make the function equal to negative 4, which any God-fearing function would have done in the first place. Okay. So really, I've kind of cheated and looked at the graph, and I know when x is equal to, whoops. Oh, when x is equal to negative 2, that basically I can't really do that because of the previous definition of the function. But you know, if I didn't have to worry about that, if it wasn't for that restriction, f at negative 2 is equal to negative 4. And so if we just say that a is negative 4 when x is equal to negative 2, and our function is equal to a when x is equal to negative 2, then we can just fill in this silly hole down here and make the function continuous. Now, there's a little problem. Nervous laughter. And that is, this is saying when x is not equal to 2, and when x is equal to 2. And so really, it's not going to matter what you choose for a if this is really the piecewise function you're talking about, because this thing is discontinuous when x is equal to negative 2. So we're not going to be able to fix it when x is equal to 2. All right, so let's take a look at this next one, 2b. We'll see that this is a rational function when x is less than 1, and then it's some value of a when x is equal to 1. And then it's going to be this other slightly different rational function when x is greater than 1. And so what they've done is they've chosen a to happen when x is equal to 1. And that's a good thing because that's where our discontinuity is. But there's been a subtle change in the function when x is changing from being less than 1 to being greater than 1. And of course, what you see when you graph it is it's this nice line. In other words, probably if we do the factoring, things are going to cancel top and bottom. We're going to get a nice linear function. And then when x gets to 1, suddenly we're going to get this terrible rational function. It's going to be a reciprocal function, and it's like asymptotic with the value x equals 1. And so there is nothing we can do to fix this one. It's just broken. So it's not going to work for any value of a. Now, to do this nice and scientifically, what you're going to do is you are going to factor this, and you're going to find out that sure enough, this is going to factor into like x minus 1, x plus 3. And the x minus 1s are going to cancel. It's going to make that nice line. It'll be negative x plus 3. Okay. Anyways, when x is greater than 1, you're going to factor it, and you're going to find out that this winds up being like some like crazy reciprocal function. There's going to be something in the bottom that doesn't cancel. And so you wind up with it being asymptotic to x equals 1. So there's nothing you can do about it. Nothing's going to cancel top and bottom. There's no way you can make this thing continuous. Okay, so the last question. Basically, this is a parabola. It's an upward-facing parabola. When x is greater than some value of a, and it's 2 when x is less than some value of a. And so it's a parabola for a while, and it's a straight line for a while. We need to find values of a that make it continuous. And so if we actually plot this in Desmos, and I've done it very cleverly right here. Okay, so I've made this slider A. And that is the endpoint. Really what we're trying to do is we're trying to find the place where the line y equals 2, or f at x equals 2, intersects with the parabola 2x squared minus 5x minus 1. Okay, so I've made this so I don't have to do any algebra. I've made it in Desmos, so there's the first place. When a is negative 0.5, these two touch. This thing is continuous. It's not differentiable everywhere, but it's continuous everywhere. Okay, and then I can increase my a value, and when I get to, what is that, 3? Sure it is. When I get to 3, this thing is continuous once again. Okay, so there are two possible values of a. How do you find them? Well, oh, did I ever just wreck that?